Okay, so last time we talked about graphing quadratic functions and inequalities in standard form, so this time we're going to talk about it in vertex form. So again, like with the previous section, we're following along in the textbook, sections 3.1 and 3.7, for the Glencoe Algebra 2 textbook, the 2018 edition. So vertex form, as we discussed last time, looks like this. The AX, the expression x minus h squared plus k. Well, now the reason why it's called vertex form is because the vertex point appears right in the equation itself, h and k values. So unlike in standard form where we had to go find the vertex point, here it's given to us directly. So we can just simply plot the points. And again, the same 2 points, we use the same idea behind finding them. In this case, because y-intercept is not as easily seen, we're going to use the a approximation as like a slope idea behind actually plotting and seeing what this curve really looks like. Alright, so we want to graph this particular function right here. So f of x equals a negative 3, x minus 4 squared minus 2. So our vertex point would be at positive 4, negative 2. Like with our absolute value, the x-coordinate is the opposite sign, the y-coordinate is the same number. So when we plot positive 4, negative 2, we're going to be down here. And then, since our a value is a negative 3, we can approximate that as going down 3 and left and right 1. Like I said, this only works in the 1 to the left and right direction. It doesn't work for anything else. Again, feel free to plug in positive 3 into this function. You'll find you get negative 5 or positive 5. You'll see you get negative 5 as well. So it's just an equation. There's no inequalities to worry about. We just connect them with our lines, and there's our quadratic function. A vertex form is very much easier than dealing with it in standard form. All the information is pretty much right there for us. So for this one right here, again, the x-coordinate is the opposite sign, so it'll be negative 3. Y-coordinate is the same, so it's negative 1. So we go negative 3, negative 1. Here, the approximate slope is 2, so we're going to go up 2 and then left and right 1 from there. Again, we connect them to create our u. And there's our quadratic function. Very straightforward. You are more than welcome to plug in other values if you're not quite comfortable with the slope approximation. There's a whole bunch of other ways you can find these symmetric points. Do keep in mind other teachers might require you to find more information. They might want to know where across the x-axis, where across the y-axis, things of that nature, in which case you do either set equal to 0, set x equal to 0, find whatever it is you're looking for. But for this class, again, I just want the main basic shape, vertex point, and then the 2 symmetric points. So in the inequality, same process still. Our vertex point would be at negative 2, negative 4. So there's our point right there. Our slope, well, there's no number there, but it's a negative sign, so that means the slope is a negative 1. So we'll go down 1 and then left and right 1. Okay, and then from there, we want to, again, create the general shape of the curve. So we're going to go ahead and, since it's less than, no equal to, it's a dotted line to create it. And then from there, since it's less than it, we have to be under the curve, so that's why we'll be in here for the region. Again, less than always means under, greater than always means above. So inside or outside is not really relevant to it. It's just a matter of whether it's under or above. Alright, so for this one right here, a vertex point, since it's negative 3, it will be positive 3. The y is negative 4. So we go to x is 3, y negative 4. Here our approximate slope is a 2, so we'll go up 2 and then left and right 1. And then from there, we want to create the general shape. So since it's equal to, we're going to do a solid line. And since it's a less than, we have to be below it, so then we're going to be everywhere on the outside. Okay? And that's it for graphing quadratics in vertex form. It's much simpler than standard form. Just simply by the nature of the actual equation itself. Standard form is generally more useful for a lot of other things, though, so don't expect you to see problems that are never in standard form. particularly when we talk about factoring and solving them, which is something we're going to be focusing most of the remaining next couple of videos on. Alright, so I'll see you next time.